Hello everyone, my name is Pisek or Benz. Welcome to Keston. This is the second video in a series that we will summarize a lecture series, the 2025 Agentic AI course as offered by UC Berkeley RDI. For a full playlist of our summary videos, take a look at the description below. Also, don't forget to subscribe to get the AI insights that build your foundation solid. A disclosure about the summary video is that it's made with the help of Gen AI, especially Notebook LM, and I did my best to maintain its factual accuracy. The second lecture is about the evolution of system designs from an AI engineer perspective, which was delivered by Yangqing Jia, who at the time was working as a VP of AI systems at Nvidia. Here is a summary.
Have you ever stopped and wondered what is actually going on under the hood of something like ChatGPT? Well, it isn't magic. It's an incredible story of engineering, and it's evolving at a pace that is just mind-bending. Today, we're going to pull back that curtain and look at the engineering journey that's powering this entire AI revolution. This is a summary of a lecture titled Evolution of System Designs from an AI Engineer Perspective. Now, what's so cool about this is that the insights are coming straight from the front lines. We're talking from an engineer who helped build foundational tools you've probably heard of, like Caffe, TensorFlow, and PyTorch. So yeah, we're getting the story straight from the source. And really, this quote sets the stage for everything we're about to talk about. This bitter lesson is key. It explains why, after decades of trying all sorts of different complex approaches, the methods that can harness the most raw computing power have, at the end of the day, won out. It really is all about scale. Okay, so here's our game plan. First, we'll dig into the surprisingly simple idea at the heart of all this AI. Then, we'll jump into the fierce competition to build bigger and better models. After that, we'll follow the money, see where the value is actually being created. Then we'll look at the massive infrastructure underneath it all, and we'll wrap up with some key lessons from the field. All right, first up, AI's big secret, and it's a good one. It turns out that all the incredibly complex, almost magical behavior we see from large language models, it's all built on a foundation that's shockingly simple and almost a century old. And that foundation is this: next token prediction. Seriously, at its core, that is all a model like GPT is doing. It looks at a string of text and just makes a highly educated statistical guess about what word or token should come next. The magic is that it's doing this billions upon billions of times with an incredible memory for patterns it's seen across the internet. Now, check this out, because this is a fantastic analogy. Go back 100 years and think about designing a Chinese typewriter. With thousands of characters, you wouldn't just arrange them randomly, right? No, to be efficient, you'd group characters that often appear together. Why? To minimize how much the operator's hands have to move. That fundamental logic, predicting what comes next to be more efficient, is the exact same principle that powers modern AI. It's just scaled up to a planetary level. So, this simple idea of next token prediction has completely unleashed what you can only describe as a Cambrian explosion in AI development. And that brings us right to our next section, the Great Model Race. Just to give you a sense of the scale we're talking about, 4.9 trillion. That's the rough number of tokens these models are processing. Not per year, not per month, every single day. That's a 10-fold increase in just the last year alone, which shows you just how explosive the demand for this technology has become. And all that demand is fueling this incredible competition between two main camps. On one side, you've got your closed-source giants, think OpenAI and Google. Right now, they're the leaders in pure quality and reasoning. But on the other side, the open source community is catching up at a breathtaking pace. What used to be a technology gap of over a year is now down to just a few months. And this timeline just shows you how fast things are moving. We're not just making the models bigger. The core algorithms themselves are evolving at lightning speed. We went from the basic transformer architecture to something called mixture of experts, which is kind of like having a whole team of specialized AIs that only get called on when they're needed. It's way more efficient. Then came techniques that let a model basically think longer on a hard problem to get a better answer. And now we're moving toward reinforcement learning, teaching models to plan for long-term goals, not just spit out the next word. Okay, so this incredible race is cranking out more and more powerful models. But so what? How does all that power actually translate into real-world value? That brings us to our third section, apps, users, and money. So if you look at where AI is making waves right now, the market is completely dominated by consumer apps. I mean, that space is thriving, it's competitive, it's exciting. But the enterprise space, selling AI tools to big businesses, that's growing a lot more slowly. And we're about to find out why. The real money, the sweet spot right now, seems to be with what people are calling the prosumer. These are professionals, coders, video editors, consultants who are embedding these powerful AI tools right into their daily work. Think of a programmer using an AI assistant to write code faster, or an editor using AI to automate tedious tasks. These users see the value immediately, and they are very willing to pay for it. So why is big business slower to adopt? Well, it all comes down to the dirty work. You can't just drop a chatbot into a major corporation and call it a day. You have to integrate with all their legacy systems, you have to handle security, user permissions, access control, you have to connect it to all their messy internal data. It's just a much, much heavier lift. Of course, all of these apps, all of these models, they have to run somewhere. And that brings us to the massive and often totally invisible engine that's powering this whole thing, the new pillars of cloud computing. Just look at how the cloud has changed. Back in the 2000s, it was all about serving websites. Lots of data moving in and out, that's I/O or input/output, but not a ton of heavy-duty calculation. Then the 2010s brought big data, which needed more complex number crunching. But today's AI cloud, it has completely flipped the script. It is all about raw computational power. Compute is now way, way more important than just moving data around. And this huge shift is leading to a really surprising trend. We're kind of going back to the future. We're building systems that look a lot like the old mainframes from decades ago. Instead of thousands of separate individual servers, we're building these giant, integrated rack-level systems that are just packed to the gills with GPUs. And the secret sauce that makes this all work is a technology called direct memory access, or DMA. This is a game changer. It basically lets all the processors inside one of these giant racks reach directly into each other's memory without having to constantly ask for permission. This makes it radically simpler to run a single gigantic AI model across the entire system, letting it all act like one giant cohesive brain. And why do we need all this crazy new hardware? Well, this chart says it all. Just a few years ago, a state-of-the-art model for understanding images had maybe 6 million parameters. Today, a language model with 8 times billion parameters, that's over 1,000 times larger, is considered small. This absolutely explosive growth in model size is what's driving this entire hardware revolution. Okay, let's bring it all home. We'll wrap up with some key lessons and a quick look at the future, pulling from the hard-won experience of the folks who are actually building these incredible systems. For anyone out there thinking about building a company in the AI space, the advice from the front lines is pretty clear. First, don't even try to compete with Google and OpenAI on training a new foundation model. The cost is just astronomical. Instead, focus. Pick a specific industry, a specific vertical, understand their problems inside and out, and then apply AI to solve them. And interestingly, the biggest roadblock for most startups right now isn't the tech, it's the supply chain. Just getting your hands on enough GPUs is the real battle. And a final, absolutely critical lesson is about people. To build these systems successfully, you have to bridge the gap between two very different worlds. You need the people who speak the language of research, of academic papers, of complex math, of abstract concepts. And you need the people who speak the language of engineering, of infrastructure, of system stability, and of what to do when everything breaks at 3 in the morning. Making those two groups talk to each other is the secret to success. So we'll end on this question. We've seen this undeniable trend. The thirst for more and more computation is pushing us back towards these giant, centralized computing systems, these modern mainframes. As that trend continues, what does it mean for the future? Who gets to access all this power? And how is that going to shape the next wave of innovation? That is both the challenge and the opportunity that lies ahead.